Let's start with the agenda for today's session is uh, again guys, if someone just wants to tell what do we mean by a dynamic array, because I'm assuming like you guys are already familiar with arrays. Okay, so let's start from the very basics. Like I would be swiftly going through these basics. Okay, so what's a data structure, right? Data structure, when we talk about a data structure, so the way we define it is a way of organizing data. Like there are many data structures, but we choose one data structure over the another based on the situation. So one of the main things that drives our decision is how conveniently can we access the elements from that data structure, right? Another way to say what a data structure is, you can call it as a collection or group, whatever you want to say, collection of data types or collection of data of different data types. So just to give an example, like the way data types and data structures are different from each other. In data types, we generally only store a value, and in data structures, we can store a group of data in any data structure. So example would be an array, linked list, tree, and some languages like in some low level languages, things like classes and collections would also be uh, considered as data structures. And on data structures, we can perform some operations which we cannot perform on simple data types. So what are these operations? Insertion of any element into a data structure. Another operation would be deletion of any element if you want to delete any element. Every data structures comes with some methods that you can apply and do these operations, right? We would be looking on those methods in the future. Another would be accessing elements. So like when we do a of I, so basically this is an accessing operation. We are just accessing the element I from the array A, right? So that's pretty much all about what data structures are. Let's start with today's data structure, which is array. Like there are a few things, few rules which define an array. First would be like an array is a group of data or a group of elements which are stored in a continuous chunk of memory. So group of elements which follow these following conditions. So first would be all the elements in an array are of the same data type. Another thing would be like the way these elements are stored are in continuous chunk of memory. And the third thing would be uh, same data type, same. Okay, another thing would be fixed size. Before defining array, it is compulsory that we know the size of that array. And what is the size of an array? Size of an array is defined as the number of elements in that array. Number of elements present in that array. Okay. So if these things are clear, another thing, yeah, there are two kinds of arrays. One is one-dimensional array. So this would be like storing data in list type. Second would be multi-dimensional arrays. So this would be in the tabular form. Like when we define matrices, this is the way we store them. Okay. So like, why do we actually use arrays? if we already have data types, cannot like why cannot we use simply data types? Why do we have to use arrays?
Because we don't need like to use each variable on the like because we will have a lot of variables. This is why we use like arrays in order to prevent that.
Yeah, great. Like that is the main reason why we use arrays. So let me just quickly go through the advantages of arrays. First, as Mohammed suggested, that we can access all the data using a single variable. Multiple data represented by single identifier or variable. Okay. Second, and one of the biggest advantages of using an array is random access. Like, do you guys want to tell what do we mean by random access?
Yes, random access is like we could access it just by like defining an index, and we could access to a particular variable in the list,
Yeah,
particular
definitely.
elements. I mean,
Yeah. Just using the indexes because in array all the elements are indexed. Yeah. If that's clear, let's try to break down the random access part. Without taking too much time, let's do that. So the reason why we can actually access the elements in an array in order of one time complexity. So this is because we can access elements in O of one time complexity. And why we can do that? The main reason is because, like as we mentioned in the previous slide, arrays are stored in continuous blocks of memory. So let's just try to understand that. Suppose we are told to create an array of 10 numbers. Okay, so I have defined an array with the name A, and let's say all the elements are of type integer. Because all the elements are stored in continuous chunk of memory. Guys, can anyone tell me like what is actually stored in this A variable? When we define any variable of array type, what is actually stored in this variable A? Anyone?
It is actually stored in the
I
first index, I think.
will
Please come again. Like what are you?
Indexing the first index.
Yeah. So the address of the first index.
Index,
Actually,
yeah.
what A stores is address of first index, or this index is also known as base index. So, like in real life scenario, these addresses are stored in hexadecimal values, but uh, just for the sake of simplicity, let's take the example that the zeroth element has a memory of, this is the zeroth element, and let's say the memory address location is 100. And guys, we also know like every data type possesses a fixed amount of memory in the RAM, right? So let me quickly recap this. Data types, different data types have different amount of memory. So a character would have 1 byte of memory. Any variable of type integer have 4 bytes of memories. Then double, I think, um, double I think has 8 bytes, right?
8 byte, yeah.
Yeah. Float again, 4 bytes, and 1 byte. We know 1 byte is 8 bits. Okay. So since all like different kind of data types consist of different sizes, so like in this example, we are talking about integers, right? So A was of type integers. and the size was 10, right? If like when we are talking about random access, suppose we want to find the sixth element here. Why it is random access? Because what the compilers actually do when you try to write this, since every block is of size 4 bytes, because it is storing integers, all it has to do is take the address of the base index, which is 100, and then add the index times the size of the memory taken by every element. So that would be 4 bytes. So be 124. This would be the location of the address of A of 6. And because we have seen in the previous session that these additional operations and multiplication operations are of order 1, that's why accessing takes place at order 1 time. So that's basically what random access means. Any doubt in this?
So all of that's happen, and so the compiler do all these operation for us. So this is how like it reaches, like if we have an index and wants to reach it, so all of this happen under the hood and reach the particular index we want, right?
Yeah, right. It happens under the hood, and the compiler takes care of all these operations. Okay, so great. I think we can jump to dynamic arrays. Let's do one thing, just to give the perspective of why random access is important sometimes. Let's quickly look at linked list. Even though we would be talking about linked list in the future from the very basics, let's quickly look how a linked list work. When we saw in array is nothing but a continuous chunk of memory, right? But in linked list, what happens is linked list does not need to be stored continuously. And why? Because in every node, this is known as a node, and every node there are two things that we store. One is the value of the element value, and another thing that it stores is the pointer to the second node. So this would again contain the value. So if we are storing integers, the value of integer would be stored in this node, and another thing this node would contain, again, the pointer to the next node. We would be looking at these things, these pointers and nodes and linked lists in future sessions, but just to give the comparison with arrays. So like we saw in arrays, the reason why we could use the benefit of random access was because it was continuous chunk of memory, and the compiler only has to like do the multiplication and submission operations to find the exact location of any element. In this, you cannot take the benefit of random access because the memory is not continuous. So you have to traverse node by node. If you want to find what is stored in this node, you have to go, you have to start with the first node, then follow this pointer, go to the second node, then follow this pointer, then go to the third node, and finally you when you would reach to the desired pointer, you can give the value that is stored in there. So this is not in linked list, it is not random access. So we have just seen that access in arrays are of order 1. Guys, what can you say about the assignment operation in arrays? What would be the time complexity of assignment operation in arrays?
Assignment operator, you use order of n.
Order of n.
Order of 1.
Order of 1. Yeah, right. Order of 1. Time complexity for assignment operations. I think we can start with today's questions. They do need some sort of thinking. Though it is very easy if you can try it on your own. Reverse an array of size n. Okay, this is like this is the code that you want to write. You're given an array, let's say a, and the size that is given to us is n. We need to just reverse this array, and we need to write a function for this. Do you want do you guys want to try it on your own? You guys can take about a couple of minutes.
Are we actually sorting it or?
No, not sorting. We don't have to sort it. We just so let's take an example. Suppose to
Okay, we are making it in reverse. Okay.
yeah, we are just reversing it. So this is not sorted and you do not have to sort it. So if this is the input array, your output should be
We can actually start from the last index and
what was your approach?
if you start from the last index and
Yeah.
are pushing it
And
from down and assigning it
okay.
to the
Okay, but is this the approach what would be the space complexity in this approach? Like, are you reversing the array in the place, or are you using some extra space to do that?
maybe another array.
Okay, so the approach that Eol is talking about. Let's take this is the array. Let's take a simple example. 1, 2, 3, 4, 2. Okay, and now we want to inverse it. So what Eol suggests is we can start from the end, and before that. So you are suggesting we start with a different array, right? Of size
Yeah.
similar to this. Okay.
Yeah.
So let's say, let me do it in one more step. Size of a dot length,
Yeah.
and then b would be, let's just initialize it with
Size of A, yeah.
and now we are running a loop from
Int
mm,
5.
mm,
4, I think it's 4.
yeah, let's call it n. So n minus 1, we are starting from the back, right? And
Yeah.
we are going
Greater than, I think it's actually greater than.
greater than 0. Okay.
I minus 1, yeah.
You can simply do it. Bi equals to a of n minus I, right?
Yeah.
So yeah, this would give us the reversed array. But if you are asked to do changes in the original array, then you have to run another for loop. And again, if you are asked to do changes in the original array, then again you would run a loop from I to 0 to I less than n, I plus plus. And now we would replace the values b with a again. This is in the case when you are asked to do the changes on the original array. Otherwise, you can simply return the b array in the previous slide. Okay, so this approach is right. We can do it in this way, but like in this approach, we definitely used additional space. Suppose the interviewer does not want you to use any external any additional space, and now the interviewer is telling you to optimize your code and do this without using any extra space. So how can we do it now? Because in this approach we have used extra space. Okay, first of all, guys, like Mohammed, is this approach clear to you? Are there any doubts in this approach?
I had to reconnect because I didn't fully see the full screen. But
Okay, okay,
it's fine. I will rewatch it again on YouTube because
okay. Okay. So since in the previous approach we were using extra space, let's try to optimize our solution. So mm, say this is our input array and we want to reverse it. So the approach now, what we are going to do is initially we just copied them in the reverse order and then using another array. But in this approach, we would be swapping the initial elements with the uh, elements from the back. And if the number of elements are odd, the middle element would be swapped with itself. So let's try to write a code for this. Okay, so in this case, what we can do is, okay, yeah, let's, I have to discuss one more thing before starting the loop. If I have to, suppose I'm in an array, and since we are starting from both the sides and we are just swapping it, so if I have to swap an element I at like any element which is at position I from the beginning, which element should I uh, swap it with? Given the final element is n minus 1, which element should I swap with? Which element should I swap I with?
is it
Yeah, go on. What were you saying? Okay, so guys, isn't it obvious that we would be swapping, since we are swapping the first element from the beginning with the first element from the end? So this is, if you can see it in this way, we are actually swapping the ith element with n minus 1 minus I element from the back. So this is actually the most important part in this while writing the algorithm in this question, to understand that we are going to swap uh, ith element with n minus 1 minus ith element. Is it clear?
No, I'm not actually getting it.
Oh,
Maybe if you give us an example.
okay, okay, yeah, right. Let's take any random example: 3, 4, 5, 6, 7, 8. And indexes would be 0, 1, 2, 3, 4, 5, 6, and 7. So what we're basically trying to do is we would be swapping the 0th element from the beginning with the 7th element from the end. So first element from the beginning swapped with the first element from the end, then second element from the beginning swapped with second element from the end. This would, swapping the first element would give us 8 in place of 1 and 1 in place of 8. Then if we swap these two elements, this would give us 7 here and 2 here. Then 3 would be swapped with 6, 6 and 3. And finally 4 and 5 would be swapped, so 5 and 4. So if you can see that this is the desired reversed array, and since we are doing the swapping in place, we do not need any extra space in this algorithm. Does this make sense?
Yeah.
Okay, so since we would be swapping in this case, let's talk a little bit about how we swap in programming. Because swapping, we would like swapping two elements. This is a very common thing to do in programming. So let's take this example. You have two glasses of milk. You have milk in both glasses. Or let's say uh, you have milk in one glass and in other glass you have orange juice. Okay. And you want to transfer, and this is the glass number one, and this is glass number two. You want to transfer milk from glass number one to glass number two, and you want to transfer OJ from glass number two to glass number one. Can we do this swapping using these two glasses only? Can we do that?
We can actually use another glass and
Yeah. So let's call it the temporary glass. And what we can do is uh, we can first transfer the milk
first, yeah.
from first to this. Then OJ would be transferred to the first, and then
Yeah.
we can do the temp to second. Right? So this approach we would be following in the code when we write this the code for this approach, swapping the elements from start to end. Let's do that. Which before starting the for loop, let's take an how many variables would we be needing? Let's start equals to 0, I less than n, I plus plus. A of I we would first use the temp variable and store the value of A of I in this. Then, since A of I is stored, now what we can do is n minus I minus 1. Since we are swapping the ith element with n minus I minus 1 that we saw in this previous slides. In this place, you can do this. And finally, in place of, is this correct? Okay, no, not this. Instead of temp, we'd store A of I here, and now in place of A of I, we can
actually
store,
save the temp, yeah.
and here it would be A of n minus I minus. Is this code correct, guys? Would we find our answer doing running this code, or is there anything wrong with this code? Can you guys see any problem in this code? So let's see. So does anyone want to give any answer? Is there anything wrong with this code, or is this code correct? Okay, see, since we are, yeah, please go on if you have to say anything.
No, I'm actually trying it.
Okay. So if you see, we are running this loop n times. So what would happen is, if I run this loop n times, what would end what end up happening is after your loop reaches this point 4, so after your loop reaches index 3, it would again swap back to the elements that are here, so 4, 5, 6 and 7. So let's quickly do the dry run for I equals to 0. A of 0 and A of 7 are swapped, right? For I equals to 1, A of 1 is swapped with A of 6, A of 2 gets swapped with A of 5. Sorry, this is 7, yeah, 5. Then A of 3 would get swapped with A of um, 4. And if we keep running this loop, this is I equals to 2, for I equals to 3. Now, after 3, if you keep on running this loop, what would happen is you would again swap I of 4 with I of 3. And for I equals to 5, A of 5 would get swapped with A of 2. So you see, if we progress after this point, we would again is swapping the elements, which would make our whole code pointless. Does this make sense? That we have to stop at n by 2. If you stop at n by 2, you will reverse the entire array. But if you keep on doing that again, if you run till the last point, you would end up with the array that you started with. Does this make sense?
How do we know that this is a time for breaking the loop?
Yeah, so that's why we did the dry run. After you reach the half point of the array, you see there would not be any elements left. So this would be swapped with the last element. This gets swapped with the second last. Third would get swapped with this. Four would get sorry. Third would get swapped with 6. And when you reach 4, 4 would get swapped with 5. So you see there are no elements left if you reach the half point. Does this make sense?
What if it's
Yeah.
an odd number?
Yeah, let's do that. So 1, 2, 3, 4, 5. Let's take 5 elements. In this case, first would get swapped with 5, second with this, and you can run it till here, because even if you so there are 5 elements, so what you will do is n by 2 is equals to 5 by 2, which would give you 2. So you would run your loop until I less than 2. So this would be 0 and 1. So here your loop would stop.
So first
But
we have to store.
yeah, so even if you run this loop till this point, then 3 would get swapped with itself. So it does not make much difference. You can stop at 1, or even if you want, you can stop till the middle point, till the middle array.
I get it now.
Because 3 would, in the reversed array also, 3 would remain in the middle. So that would not make any difference.
Okay.
Okay, so we were trying to write the code. Here, we do not have to make any changes. You can simply do, you can simply run the code till n by 2. and this would give you the correct result. Okay, so this was reversing an array. Now, do you know what a subarray is? Suppose the question is reverse subarray from L to R in an array of size n. Do you know what a subarray is?
No.
Okay, so if this is the array that is given to us, let's say there are size of this array is n. This is given to us, and L is any element, and L is an index, and R is another index. So what subarray is? Subarray means a continuous subset of the given array. So from L to R, if you cut this part out of this array, this would be defined as a subarray. So what is not a subarray? Let's take an example. So this is our array. What are the valid subsets? 2, 3, 4. This is a valid subset. 1 is a valid subset. All the single elements are valid subset. The complete array is also a valid subset. 4, 5, 6, 7 is a valid subset. But 1, 3, 4, oh, sorry, not subset, subarray. These are valid subarrays. 1, 3, 4 is not a valid subarray because we are missing the element 2. These are not continuous. Okay, did you get it? 1, 3, 5 is not
It
a
has
subarray.
to be subsequent.
Yeah, subsequent. Okay. So our question says, given an array of size n, you have to reverse a subarray from L to R. So do you want to do this on your own? You can take 2 minutes if you want to do this on your own.
Can we start from the given index?
L, right?
Yeah. Can we use the same approach that we did before?
I starting from L to till where?
L over 2.
L over 2. Wouldn't it be instead of L over 2, say the index given to you is L is given to you. Let's take this example.
Not the L, but the size of the subarray.
Yeah. So this is 1, 0, 1, 2, 3, 4, 5, 6, 7. So the correct answer would be 6 plus 1 by 2, 7 by 2. That would give us the size of the array. So L.
Why we are adding 1?
No, we are not adding 1.
No, I'm not actually getting it.
Let's take this example again. Array given to us is 1, 2, 3, 4, 5, 6, 7, and 8. This is the array given to us, and what we are saying is, let's take the example. L given to us is, in this case, 1, and R is 6. So this is L and R are indexes. So
the index, yeah.
L would be the first index, so that would be the element 2,
Yeah.
second, sixth index, and finally 7 index. So what we are trying to do is we are starting from L, as you suggested, and
Yeah.
we would be going till L plus R by 2, because L plus R by 2, which in this case would be, let me do this here. L plus R by 2 in this example would be 6 plus 1 by 2, right? This
Yeah.
would give you the element 4. Sorry, okay, I see the problem. Earlier what I said was L plus R by 2 would give you the size of this subarray, right? But
Yeah. Yeah.
yeah, that was wrong. It would not give you the size of the subarray. It would give you the middle element
The whole.
of L and R. Okay, so like in the previous approach, you were going till the middle element. So in this approach, we are also trying to get to the middle of the subarray. So L plus R by 2 would give you the middle element. Sorry, that was my mistake. Is it clear now?
Yeah. Yeah.
Okay, and the rest of the code is similar. Okay, would you like to do one more question, or should I give you that in the homework? However you want.
You can continue.
Okay. The question says, given an array of size n, find for how many elements there exists or there is a strictly smaller element and a strictly greater element. Is the question clear? Let's take an example. Suppose you are given this array 1, 3, 2, 11, 7. So this would be the input to your function, and what you uh, uh, the expected output would be an integer that would give you the number of elements which have a strictly smaller element and a strictly greater element. So in this case,
By 1 and 11.
yeah, in this case, how many elements have a strictly greater and a strictly smaller element in this example?
1 and 11.
No, no. So we have 3 elements, 3, 2, and 7, because one does not
Okay.
have, yeah, one does not have any element which is smaller than it, and 11 does not have any element which is greater than it. So we need to find the number of elements which have both at a strictly greater and a strictly smaller element. Would you like to try this on your own?
No, that's actually the hard one.
Okay, so let's do this. Let's take an integer. We'll say Where was it? Let's try to discuss the approach. What can we do in this case? If you have to find the number of elements. So this was the example, right? And we need to find all the elements which have uh, a strictly smaller and a strictly greater element. Can I say that if we find the minimum element in this array and the maximum element in this array, so let's first try to find the strictly smaller element for all the elements. If I find the minimum element in this array, all I need to check is I have to run another for loop, and in that for loop I have to check if a of I is greater than min. That means that I have uh, an element I which have a strictly smaller element, right?
Yeah.
Right. And because I need to find both the things, whether an element has a strictly smaller and a strictly greater element, so we would find both minimum of this array and the maximum of this array, and after that what we can do is uh, after that I have to run an AND condition and check whether a of I is smaller than max. If both these conditions are true, in that case we can increment our count variable. Because for the ith element, we have checked that it has a strictly smaller element which is minimum, and also it has a strictly greater element which is maximum.
Yeah.
So in that
yeah.
case, yeah.
But first we have to find the min and the max, right?
Yeah, we have to find min and max. So for that, let's quickly write the code for this. Let's run the for loop from I equals to 0. For that, we have to this is the array given to us, whatever it is. We would find the length of this array, a dot length. We would initialize maximum with the first element. We can do this,
Yeah.
right?
Yeah.
And
Minimum.
initialize minimum with also the first element.
Yeah.
And now we can run our for loop. One more variable is the count variable. Initially it would be 0. Now I can run the for loop. From I equals to 0, I less than n, I plus plus, and if uh,
Min,
a of I
min.
is lesser than min, then we would update the value of min.
Yeah, we are assigned. Yeah, we are assigned the value of
A of I. And similarly, if a of I is greater than max, we would update the value of max. Right? And so running this loop would give us the value of maximum and minimum. After that, we would run another for loop. And here we would simply check if a of I is greater than min and a of I is less than max. If this
Yeah.
condition comes true, then we can
count.
increment. Yeah.
Yeah.
And finally return our counter variable.
You can see out or print out. Yeah.
Yeah.